Okay, so I'm going to do or redo some of these problems because a few guys have some other things to do, and you might have missed a couple of questions here and there. So, question one says, well, basically saying that Missy wants to take a what do you call have a 91 average as her final. Um, her current scores, are 94, 83, 86, and 90. What does she need to get on the last test? So let's start by, writing it up. All right, so here, well, this is how I would do it. I'd write what I know. I know that she wants to take the average of her 5 tests, right? And I don't know what her fifth score is, but if that's what we're trying to find out. So her first 4 tests plus her fifth test divided by 5, because that's what we're doing, right? The average, the mean, we divide by 5, and that should give us, and that she wants that to equal 91. So she wants to what do I need to get on that last test? So one way of solving this, and I showed you in class, was to cross multiply this, right? So if you put both of them over 1 and I cross multiply, I end up multiplying these two. Now, if I multiply these two, 5 times 91, I get 455. And if I multiply 1 times this whole thing, it's just that whole thing. It's just 94 plus 83 plus 86 plus 90. By the way, when you're multiplying, you're going to put it in parentheses, but it's okay because it's multiplying by 1, so it ends up being the same thing. So the main thing here, and I'm going to step back here, is knowing that I'm going to divide that by 5 to give 91, right? So this is the main thing. So if you cross multiply, like I said, 5 times 91, you get 455. And on this side, you get that whole thing. And then I'm just going to make life a little easier. I'm just going to add 94 plus 83 plus 86 plus 90. Turn my calculator on, it will actually calculate that. Plus 90, and you get 353. So instead of writing 94 plus 83 plus 86 plus 90, I'm going to write 353. And then plus x, right? Remember, so that this is gone because the cross multiply was 91. So now I have this. So it's a one-step equation. 353 plus what number equals 455? And if you just subtract 353 from both sides, you end up getting actually 102. So poor girl, she has to get 102 on her test. So basically, she has to get perfect on her test plus get 2 bonus points from watching the video. Okay, so this is how you would do it, or I would do it. Okay. Question 2 here talks about, this is remember what statistics is, right? We are going to use a sample, right? Because I don't have the means of surveying everybody in the population. So we take a sample, and then we can sort of see how the population is going to behave. So we took a sample, Mr. Roy took a sample of the 60, and he used the 60 boys on the football team. And he asked them about their favorite, camp class. Right? So if you go to camp, these are some of the classes that were offered. So, and these were the results. So we want to know that if we were to ask 265 people, how many of them would have said taste of nature? So let's use what we got on our survey. So in our survey, we got that how many people said yes to Taste of Nature? Taste of Nature. 5 kids said they loved the Taste of Nature class in camp. So 5 out of 60. So in our survey, that's how the sample behaved. 5 out of 60 kids said yes. So if we multiply that by the population, which in this case there's 265, we can sort of use that to predict how many of the 265 people would have said yes, that Taste of Nature is their favorite subject. And that's simply just multiplying. So 5 times 265 equals something divided by 60. So I'm going to write this out. So we get 1325, right? This over 1. If we divide by that 60, we get, am I doing this right? Apparently so. So I get 22.08, right? But because we're talking about people, we can't have 22.08 of a person, so this would be 23. Okay, when we're talking about people, anything that's above, we round it up. Okay, so that would be question A. Question B is the same thing. It's just you got to be careful with what the survey is asking now, or what questions is. It's saying, well, how many of the 265 would also like anything but the wall? So they would say anything but this. So this would count, 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 and this would not count. So in our survey, out of 60 people, 15 said they didn't like the wall. So that leaves me 45 people out of 60 who liked everything else. So based on that information, I'm going to multiply again that by 265 to see how the 265 would have behaved. And we're going to get 45 times 265 equals some number, 11,925, and divide that by 60. So we get 11925, 198, oops, divide that by 60 again. And the calculator says 198.75. And it says show your word, put your answer in the nearest 10. So that doesn't make any sense. I don't know what, because we're talking about people. So this would be 199. Okay? 3, 4. Oh, identify the sample. I'm sorry. So again, it's part of this question. So sample. Who was a sample? Sample were the 60 kids in the football team, right? 60 kids in the football team. 60 boys, right? What's the population? The population in this case is the 7th grade camp class. Is this a random or bias? Well, I would say definitely bias, right? Because we only asked the boys, and we only asked the boys in the football team. Definitely a select group of people, right? Remember that random, when we're talking about random, it means that everybody had the same chance of being selected for the survey. In this case, no. Okay, list 2 ways to make this this estimate more accurate. Well, we could have asked, put everyone's name in the hat and select whatever 60 randomly, put them as a list and select every 12th kid. I don't know, maybe the 7th grade camp, if they're all eating lunch at the same time, you can survey every 8th person coming to the cafeteria in camp, right? And then ask them these questions. Well, definitely a few ways of making this less biased, more random. 3, this one dealt with, and this was just generic. It was just, mean, median, and mode. So anytime you're dealing with mode, median, you need to put the numbers in ascending order. Okay, so let's do that. So I have a number is 34, 74, 77, 74, 77, 82, 83, 82, and there's an 81 there. 81, 82, 83. I saw the 81 now. 85, 86, no, 87, 88 twice apparently. 93, 94, 96, 98, and 101. And I think I'm correct. So now it's asking you for the mean. So to find the mean, we've got to add all of them up. So that's just calculator work. 93, 94, 96, 98, 101. And I get 1,174. And the mean, 1, 2, 3, 4, 5, 6. I think I'm missing a number. 34. Yeah, I'm missing a number. 34. Missing a number. Hang on a second. 34 was 34. 34 for sure. 74. 77. 81. 81, 82, 83, 85, 8, 9, 10, 11, 12, 13, 14. I'm missing my 85. 88 comes twice. And I'm missing 91. Okay, here's 91. So 1174 plus 91 divided by 15, it looks like 84.33. So if I add all of them up, my mean is 1265 divided by 15, and I get 84.3. My medium, I'm sorry, let me cross out numbers from left to right. Right, 1, 2, 3, 1, 2, 3, 1, 2, 3, and my median is 88. My mode, it's also 88 because there's 88 shows up the most, and the range is 101 minus 34, which looks like a 67. So that's, and then are there questions on this? Okay, so, and if I were to ask you which one, what do you call, best describes the center here, I would probably select the mean, sorry, not the mean, the median. Why? Because this 34 definitely made everything go down a little bit more, right? So imagine all your test grades and you get all these grades and you get the 34. The 34 definitely brings things down for you. Okay, so which group of people was most likely be unbiased? Unbiased, if you want to survey about the preference of pizza, of school pizza. Cafeteria staff, workers at pizza restaurants, students who bring their lunch, and random students throughout all lunch periods. So definitely, that's easy, right? That's what you would ask. Basketball coach at middle school wants to conduct a survey for the preference of next year's uniform. Basketball coach. Which sample will give the coach the best results? Teacher in the school, definitely not. Students in the 8th grade, definitely not, because, what about the 7th grade and the 6th grade? The basketball players from his team and the people who attend basketball games. So this one, it would be the basketball players from his team, right? Because it's the, what do you call, next year's uniform. And the only people that are wearing the uniform would be the basketball players. Okay. 6, most likely be unbiased about, okay, we just did that. Why is 5 and 6 the same? Oh, most likely be an unbiased, most likely be unbiased. Okay, no, it's the same question. I don't know why we did it again, sorry. 7, Michael surveyed every 10th child who went to a state fair about the number of rides they plan on riding. What is the population for Michael's sample? Every 10th child who entered the state fair is your sample, right? So here's everybody who's coming. So let me write this down. So here's the population. Everyone coming to the state fair, coming to the fair. And out of those, he took a sample, right? He took a sample, right? He put his hand in there and took a group of people. Who did he get here? He got every 10th child. Every 10th child. What is the population? Also, the population is not this, not every 10th child. All the people at the state fair. Every adult with children at the state fair? No. He wants to know, will be all the people, not all the children at the state fair, right? Because that's going to be all the population would be all the children, not everyone coming to state fair. So let me take that out because I didn't read it. It would be all the children, right? Because definitely children and adults have different tasting rights. 8. A sports writer wants to know which is the most popular college basketball team. Which group of people would give her the best, least biased service? So the best, right? The least. So we want to look for unbiased. Every person entering a college dining hall. Every fourth student watching a game being played. Every student at a freshman orientation. Every fourth person entering a grocery store. Well, sports writer wants to know which is the most popular college team. So obviously, if you're going to a college dining hall, let's say you go to, I don't know, St. John's, and you ask every person there, they're going to say St. John's. So that's not going to work. Every fourth dinner watching a game being played. So first of all, if you're watching a game, you're already biased, right? Because you already have a preference. Okay, so you want to be unbiased, right? So and I guess we're gonna ask everybody. Every fourth student at a freshman orientation. Well, if you go to St. John, again, I'm going to use St. John's as an example, and you go to their freshman orientation and you ask every fourth student there, they most likely will say St. John's again. But the only one that's really, really random is every fourth person entering a store. They don't have affiliations with anyone, and they might give you the least biased answer. Okay? Which of the following is something is, okay, so now we're talking about mean, we're talking about mad. Okay, so I did this with my 701 and I liked how I did it. So let me see if I can do it again. So the answers you can answer yourself. They're not that difficult to answer, but we're asked to find the mean, who has a greater mean. Then in order to do that, well, we're going to add all the numbers and divide. Which one is greater and by how much? And then we're going to talk about mad. Okay, so let's do that. So what I did in that class, and let me just get to this. So let's find the median first. The mean, sorry, let's find the mean. So let's add the left side. 77 plus 72 plus 80 plus 68 plus 82 plus 71 plus 84. I'm going to divide that by 8. And I can't add. 77 plus 72 plus 80 plus 76 plus 68 plus 71 plus 84. And divide that by 1, 2, 3 by 8. Really? Okay, I'll do this one more time. 77 plus 72, 77, 72 plus 80 plus 76 plus 68 plus 82 plus 71 plus 84. That equals 620. Divided by 8, and 77.5. God, I hope I'm doing this right. And on the other side, 60. No, I can't add. 60 plus 66 plus 58 plus 64 plus 63 plus 60 plus 55 plus 58 plus 63. And that gives me 603. And again, I hope I'm right. I'm going to divide that by 10, right? And that's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be 6.3. That one looks good. Although the other one, I think was a different number. I'm just going to do it again. 610 divided by 8. That looks better. So I messed it up quite a few times. So this one's 610 divided by 8, 76.25. Let me show you what I did with the other class. Just a different way of explaining it. So I made a number line here. Okay, not the best number line. So the smallest number was 68, and the highest number was 84. So I'm going to go 68, 69, 70, 71, 2, 3, 4, 5, 6, 7, 8, 9, 80, 81, 82, 83, 84. I'll put an X on where we have a 68. We have a 71, 71. We have a 72. We have 76. We have a 77. We have an 80. And what I told them was, imagine there was, I went in here and I put a flag here, right here on the mean that represents the mean, 76.25. And I'll call it mean. And I want you to look at how far everybody is away from that flag. All right, so I want you to think about how closer they are to the flag or how far they are from that flag. Okay, and I'm going to do the same thing on this side. So the smallest number here looks like a 55. And we're going to go all the way to a 66 apparently. 55, 6, 7, 58, 59, 60, 61, 62, 63, 45, 6, 7, 8. Okay, 55. 58. There's a 58. There's a 60. There's two 60s. There's two 63s. There's a 66. There's a 64. There's a 58. I already put that. 1, 2, 3, 4, 5, 6, 7, 8. I'm missing two more. 58, 55, 60, 66, 64, 66. It's twice 266. All right, so you get the idea. I'm probably missing one. So over here, I'm going to put another flag. And I'll call this flag, and I'll put the same color. And the flag here is 60.3. Okay, so the mean was 16.3. And I'll put a flag right here. I'll call this the mean. All right, so look at these two and tell me which of these two groups are closer to the flag. Right, which group of people are closer to the flag? Is it this group on the left or this group on the right? And that's what the MAD measures, right? How far away are you from the mean? Okay, so the further away you are as a group from the flag, the bigger your MAD's going to be. The closer you are to the flag as a group, right, in average, that's the lower your MAD is. So that's what we're going to do. So in order to calculate the MAD, we have to, what do we have to do? What I told you in class, we have to find the difference of 76.25 with each of these numbers. How far is 77 from 76.25? How far is 72 away from 76.25? How far is 80 away from 76.25? So I'm going to put a big minus sign here. I'll be lazy. So I'm going to subtract each of these 76.25. How far is 77 from 76.25? 0.75, right? And I'm going to do the same with the other ones, right? So because distance can't be negative, there's nothing going to be negative. So for how far? If you're standing on 72 and you have to walk to 76.25, you would take 4.25 paces, right? You were at 80 and you had to walk to 76.25, you would walk 3.75. Next one, 0.25. If you were at 68 and you had to go there, you would walk 8.25. If you were at 82 and you had to walk, you would go 2 plus 5.25. Let's see, hang on a second. Yeah, 5.75, I'm sorry. And then from 71 to 76.25, you would walk 5.25, and from 84, you would go 7.75, 7.25. So we're gonna, once we find the difference between each of these numbers and 76.25, we add them, and that's what our MAD is. So let me quickly add this correctly, I hope. 0.75 plus 4.25 plus 3.75 plus 0.25 plus plus 5.25 plus 7.25. I am getting 35.5, and God, I hope I'm right. And if we divide by 8, $35.5 divided that by 8, we get 4 point, and I'm going to round this, okay, 4.4. So the MAD is 4.4. So the average distance that these guys are away from the red flag, they're about 4.4 in average units away. Now, I'm going to predict that these guys are a little bit closer because they don't look as far as these guys. So, whereas here, we have to, again, we're going to go minus 60.3. Each of these numbers I want you to find how far each of these numbers are away from 60.3. So if you were at 60, how far would you walk to go to 60.3? If you were at 66, how much would you walk to get to 60.3? So you got to do that for each single one. Hopefully you're using a calculator. From 60 to 60.3, you would walk 0.3. And then you would walk 5.7. Then you would walk 2.3, 2.7, 3.7, I'm sorry. 63 would be, so this 3.7, this would be 2.7. From 66, it would be 5.7. From 60 would be 0.3. From 55 would be 5.3. From 58 to walk to 60.3, you would walk 2.3, and then from, that would be, last one's 2.7. So again, the MAD here, and let's add these numbers. 0.3 plus 5.7 plus 2.3 plus 3.7 plus 2.7 plus 5.7 plus 0.3 plus 5.3 plus 2.3 plus 2.7. And I'm getting 31. And with this one, we divide by 10 because there's 10 numbers. And we get a MAD that's 3.1. Okay, so it's not a tiny, tiny MAD, but in comparison to this group here, right, it's smaller. These guys are a little bit closer to the mean than these guys. Okay. Is there a question we have to answer? Yeah, there were some questions. Which team had the greater mean? That you can answer. Which one's greater? Which one had bigger MAD? Why was their MAD bigger? So that could be a test question. And why was their MAD smaller? Okay, so then you can talk about how far away they were from the mean. So if the numbers were further away from the mean, the bigger your MAD, the closer you are to the mean. Closer you are to the mean, the smaller your MAD. Okay. 10. So this one asks for so the question we want to answer, which one has a more variation? Okay, so which one spread out more if you want to think about it, right? So we're asked to do what is this? Box and whisker plot, right? So box and whisker. In order to do box and whisker, the two things the first thing we have to do is put them all in order from least to greatest. This one is easy. I think I can manage. 6, 8, 13, 15, 16, 22, 29. On this side, I think it's 7, 8, 10, 12, 13, 15, 22. Okay, so what do we need? We need all that good stuff there. So let me write min, max, Q1, Q2, Q3, and I'm going to write the same thing over here. Min, max, Q1, Q2, Q3. Well, min and max, super easy, right? So let's use orange for this guy. So 6, orange, 6 over here, and 8, right? Lowest and highest number. What's Q2, which is the median? Well, let's work ourselves towards the middle. And clearly there's one median, which is 15, for Q2. Now we got to look at the bottom half. And what's the median of the bottom half? It's 8. Oops, max here. So let me erase this. I wrote this wrong. The max is 29. I don't know what I was thinking. So Q1, the median is 8, right? This number right here, right? The median of the bottom half. And what's the median of the upper half? Which is between these three numbers. That's 22, and that's Q3. So on this side, the min is 7. Let me change colors. The min is 7. The max is 22. What's the median? Number in the middle. That's a 12. The middle number of the bottom half, 8. And the middle number on top half, 15. Fairly easy. So you were asked, so the thing here is we were asked to do one number line. And we're going to go from number 6 all the way to the highest number is 29. 6, 7, 8, 9, 10, 11, 12. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 28, and 29. I'm going to go one more here. That's 29. So we need a 6, and I'm going to use orange here. So we need a 6, we need a 29, we need an 8, we need a 15 for Q2, 9, 10, 11, 12, 13, 14, 15, and we need a 22, 16, 17, 18, 19, 20, 21, 22. So the first box and whiskers, yeah. Here's my whisker, here's my whisker on the right side, and here's my box. Right? So, and if you want to, you can write 25%, 25%, 25%, 25%, 25%, so you know that each of those parts are measuring in terms of quartiles. And then in red, I'm going to put the other box plot. So 7, so I need a 7, I'll put it right here. I need a 22, which is the max, so it's going to be right here. I need an 8. I need a 12, 1, 2, 8, 9, 10, 11, 12. And I need a 15. Okay, here's my whisker, and here's my box. So it's a little bit smaller, right? My box was definitely, so you can tell that the orange one has definitely more variation, right? The range is bigger, right? The range here, nothing interquartile, but the range is bigger, right? And that's it. 11. Food School Service wants to increase the number of students who eat hot lunch. You want more people to eat hot lunch. So we're going to ask a survey to determine what you prefer for hot lunch. They determine 3 ways. 3 methods are listed below. Which one would produce a random sample? Which survey options should the student council use and why? Write all the names and cards and pull them out and draw to determine who will complete the survey. Absolutely, because when we talk about random, everybody whose name is in that hat has an equal chance of participating in the survey, or being selected for the survey. Survey the first 20 students that entered the lunchroom? No. Can you imagine if you do that? It could be the whole 706 coming downstairs, and all you would get would be 706. So that's definitely biased to a certain group. Okay. So that wouldn't work. Survey every 3rd student who get off a bus, and again, wrong, because you're selecting from a group here. Only the people who are on a bus, who live in a certain area. Right? Remember, buses are designed so that you pick people from a certain whatever block radius. You know what I mean? So they could. It's definitely biased. Okay, because you're not. They don't represent the whole of the school, and that's key here. They don't represent the opinions of all the school, and neither do the 20 students that enter the lunchroom. Okay. So the only one that would work is number 1. Tell me if the following would provide either random or biased. Determining the average yearly rainfall in Kentucky by measuring the rainfall in various counties in the north, central, and southern Kentucky. What about the eastern? What about eastern Kentucky? Okay, so I guess this would be a biased because, again, you're ignoring a certain area. Okay, so if you're, I don't know what Kentucky looks like, but if Kentucky looks like this, right? So you're selecting a few areas in the north, a few areas in the south, and a few in the central. So you're ignoring this area and this area. That would be biased. Determining which sport is the most popular among adults by surveying every 5th person who arrives at a tennis match. Okay, again, biased. If you're going to tennis match, to watch tennis match, you're most likely to believe that tennis is what do you call your favorite sport. This one. So you're given two box plots, and you're asked to say, hey, and I asked you to change this question, right? What conclusion can Mr. Andrews Miss Andrews make about the performance of her first and second period class based on their medians? All right, so let's talk about medians. So first class, period A, first class, so again, was a 10-point quiz. One kid got a 2, 2 kids got 3s, 2 kids got 4s, 2 kids got 5, and 1 kid got a 6. So if we're going to find the median is these two numbers added and then divided by 2, which is obviously 4. So the median is 4. I'm going to write 4 over here. So again, you could have done this here and crossed it out like that, right? So it's up to you if you want to write all the numbers out or just cross it out on the box plot. Same thing here. Let's just cross it out. Too lazy. One from each side, and we'll work towards the middle. And obviously, you can clearly tell that this is going to be 2 7s in the middle, and therefore my median is going to be 7. So again, you can say by the median, it looks like class A, class B performed 3 points higher. Both. What else to say over here? We're basing it off the median. That's what I want you to think about here for a second. So we're basing it off the median. Just give me 1 second here.